All right, let's talk about one of the most powerful and honestly one of the most misunderstood tools in all of tech, Apache Kafka. We're going to break it down piece by piece, so by the end of this, you'll get it completely.
So the first thing that probably pops into your head is, hold on, if I need to store data, why wouldn't I just use a database, like Postgres or MySQL? And that is a totally fair question, but it kind of misses the entire point of why Kafka even exists. See, here's the fundamental difference. Your database is built for complex reads, for updates, for joins. A single write might take a few milliseconds because it's doing a lot of work behind the scenes. Kafka, on the other hand, is a pure speed machine. It's built for one thing: getting a massive amount of data onto a disk as fast as humanly possible. Think of it less like a library and more like a fire hose for data.
So right off the bat, you have to throw out your old way of thinking. Kafka isn't a database. The right term, the one you need to get in your head, is distributed commit log. It's basically a file that you can only add to. It's immutable. Once you write something, it's there forever. You can't change it. And that is a totally different way of looking at data.
To really make this stick, let's use an analogy. Picture a classic American diner. Kafka is like that receipt printer in the kitchen that just keeps printing every single order. The paper roll just gets longer and longer, you never tear it, and you never erase anything. Any cook at any time can look back on that roll and see every single order that came in. Keep that image of the receipt roll in your mind. Okay, so if Kafka is just this one giant endless receipt roll, how on earth do you keep it from becoming a complete chaotic mess? Well, it all starts with how you organize it. The first layer of organization is something called a topic. It's super simple. A topic is just a named category for a stream of messages. So if you're building a sports app, you might have a cricket topic, a basketball topic. You get the idea. It's just a way to make sure that all your cricket data doesn't get mixed up with your basketball data. Nice and clean. But okay, let's stick with our cricket topic. What happens when there's a huge world tournament going on and millions of events are just flooding in every minute? If it's just one single stream, one single receipt roll, that's a problem. Only one system can process it at a time. You've just created a massive bottleneck. And this is where Kafka's genius really kicks in. Partitions. You can take that one cricket topic and split it into multiple parallel lanes, or partitions. But here's the really clever bit. You use what's called a partition key. Let's say the ID for the India versus Australia match. Kafka will then make sure that every event for that specific match always goes into the same partition. So what do you get? You get the best of both worlds: insane parallelism across all the matches and guaranteed ordering for the events within any single match. It's brilliant. So we've talked about the logical side of things, but how does this actually run on real machines? And, the most important question, how does it not lose all your data when a server inevitably crashes? The lingo here is pretty simple. A single server running Kafka is called a broker. A team of brokers all working together, that's a Kafka cluster. And just so we're clear, in the real world, you never run just one broker. You always run a cluster. Now, why do you always run a cluster? For this one simple, absolutely critical reason: replication. Look, without replication, if the server holding your data crashes, that data is just gone. Poof. But with replication, Kafka is constantly making copies of your data on other brokers in the cluster. So if the main broker, the leader, goes down, one of the replicas is instantly promoted to be the new leader. Your apps reconnect automatically, and you haven't lost a single bit of data. It's fundamental to how Kafka provides safety. So how many servers can you actually afford to lose? Well, the math is super simple. It's just your replication factor minus 1. So if you have 2 copies of your data, a replication factor of 2, you can lose 1 broker. 3 copies, you can lose 2. It's that easy. And this brings us to what is pretty much the non-negotiable golden rule for running Kafka in production: a replication factor of 3. Always. This gives you the breathing room to lose 1 broker completely, maybe it just dies, and have another one down for maintenance, all without dropping a single message. We've spent a lot of time talking about how to get data into Kafka, but getting it out, well, that's where things get really, really interesting. This is where Kafka's true power starts to show itself. The way you read data is with something called a consumer group. Think of it as just a team of your applications all working together to process the stream. And there is one golden rule you have to understand. Within a single group, a partition can only be read by one consumer at a time.
This is super important because it stops two different workers from accidentally processing the exact same message and causing all sorts of problems.
Now, this rule has some really practical consequences. If you've got 3 partitions but only 1 consumer, well, you've got a bottleneck. That one poor worker is trying to do everything by itself. On the flip side, if you have 5 consumers trying to read from 3 partitions, 2 of them are just going to be sitting around, doing nothing. They're totally idle. The sweet spot, the perfect setup for maximum speed, is when the number of consumers in your group matches the number of partitions.
And this right here, this is Kafka's superpower. Let's go back to our cricket topic. You can have one consumer group, let's call them the scoreboard updaters, reading the data to power a live scoreboard. At the exact same time, you can have a totally separate group, the highlights generators, reading the exact same stream of data to create video clips. And here's the key. If the highlights team is slow or crashes, it has zero, and I mean zero, impact on the scoreboard team. They are completely independent. This is an absolute game changer for building complex systems.
Look, Kafka is amazing, but it's not a silver bullet. It's not always the right tool for the job. So how do you decide when to use Kafka versus some of the other popular tools out there, like RabbitMQ or Amazon's SQS? Let's break it down with a simple framework. Let's bring back our diner analogy to make this crystal clear. Kafka, as we know, is the replayable receipt roll. RabbitMQ is more like a mailbox for the chefs. Once a chef takes an order out of the box, it's gone for good. And SQS is like a Dropbox. It holds an order and makes it invisible until a worker is completely finished with it, which is great as that worker might crash halfway through.
So the decision really starts with one very simple question. Ask yourself this: do I ever, for any reason, need to go back in time and reprocess messages from hours ago, or days ago, or even years ago? Maybe you found a bug you need to fix, or you want to train a new machine learning model on all your historical data. If the answer to that question is yes, or even just a maybe, then your decision is already made. You need Kafka. The ability to rewind the tape and replay the entire history of events is its unique killer feature. No other system we talked about is designed for that from the ground up.
But okay, what if you don't need to replay data? What if your main problem is that a single event, like a new user signing up, needs to reliably kick off a whole bunch of different independent processes? One system needs to send a welcome email, another needs to update analytics, a third one needs to set up their billing. You get the picture.
For that classic fan-out pattern, there's a really standard architecture, especially in the AWS world. You use a combination of SNS and SQS. SNS acts like a broadcaster, sending the message out to everyone who's interested. And then each of your systems gets its own personal SQS queue to read from. This gives you both the fan-out and the durability, so no one misses the message. And that brings us to the final thought I want to leave you with. The tech details are important, but the strategic idea here is what really matters. Kafka doesn't just process what's happening now. It gives you the power to rewind the entire history of your business. So the question isn't just, how do I process events faster? The real question is this: if you could rerun every event that ever happened in your company, what new insights could you discover? What new value could you unlock? That's the power of Kafka.